93 minutes. That's how long Ford's chassis line took by spring 1914. 6 months earlier, the same work took about 14 hours, nearly a 90% reduction. Not because workers got faster, because the work got reorganized. Ford didn't improve the car. He broke the job into pieces and moved the product through them at a fixed pace. The factory set the tempo, not the worker. Before the line, a Model T was built like a craft project. After the line, it was built like a clock. The idea echoed a logic already used in industrial meatpacking, a process where motion and sequencing mattered more than skill. Ford applied that logic to machines, and it worked. But the line created a new problem. The pace was relentless. Turnover exploded. Absenteeism spiked. The system that made the Model T scalable nearly broke the workforce that had to feed it. This is how Ford built the assembly line, and why the fix he invented still shapes how we work today. 1910, Highland Park, Michigan. Ford faced the best problem in manufacturing: demand he couldn't meet. The Model T had launched 2 years earlier. Orders stacked up. Customers waited months. Every delay meant lost revenue. Ford needed more cars. Fast. The new Highland Park plant was supposed to solve this. Designed by architect Albert Kahn, the facility covered 60 acres, 3 times larger than any other auto plant in America. The main building ran 865 feet along Woodward Avenue across 4 stories. Nearly 4 million square feet under one roof. Massive. But size alone wouldn't fix the bottleneck. The real innovation was flow. Raw materials entered at the top floor and moved downward through gravity slides, chutes, and conveyors until final assembly on the ground floor. Engineers cut thousands of holes through the floors, creating a network that moved parts between workstations without human transport. This single change saved an estimated 30% of assembly time. Power came from an on-site powerhouse with 9 gas-steam hybrid engines producing 53,000 horsepower. Electric motors drove mechanical belting. Overhead cranes and monorail conveyors moved sub-assemblies to final assembly. The principle was deceptively simple: bring the work to the man rather than the man to the work. But in 1910, Ford still assembled Model Ts the old way. Skilled workers at fixed stations, each building complete sections, hours per car. Ford needed a breakthrough. The meatpacking parallel he'd heard about needed testing. Chicago, 1912. Ford engineers visited a slaughterhouse to see it firsthand. Carcasses moved on overhead conveyors past workers. Each worker made one cut. Just one. The animal arrived whole. It left in pieces. A disassembly line. The engineers saw exactly what they needed. The question was elegant. What if you reversed it? April 1st, 1913. Highland Park's flywheel magneto department. This is where Ford's production team ran the first real test. Previously, skilled workers assembled complete flywheel magnetos at individual workbenches. Each worker completed about 35 units in a 9-hour shift, one every 20 minutes. Production chief Charles Sorensen and engineers Clarence Avery and Peter Martin replaced those workbenches with a single steel frame featuring sliding surfaces. They divided magneto assembly into 29 operations performed by 29 men standing 18 to 36 inches apart. Each worker performed one small action before sliding the work to the next person. The result was immediate. Assembly time dropped from 20 minutes to 13 minutes and 10 seconds. A 34% improvement achieved simply by eliminating worker movement. But Sorensen kept pushing. They tested different conveyor speeds. 5 feet per minute proved too fast. Workers fumbled. 18 inches per minute was too slow. Efficiency dropped. 44 inches per minute proved perfect. They raised the line height to prevent stooping and installed a continuous chain to synchronize pace. Within months, the workforce dropped from 29 to 14 operators. Assembly time fell to just 5 minutes. Let that land. 20 minutes became 5. A 75% reduction from rearranging the same components in a different sequence. No new technology, no new materials, just different organization of human motion. Daily output reached 1,335 units with half the workers. As one motor assembling foreman admitted, "We were asleep over that job, asleep and dreaming." Ford had found something. The question was whether it could scale. If dividing magneto work into 29 operations produced these results, what would happen with more complex assemblies? If you're watching this channel to understand how systems actually work, not just who built them, subscribe. This is what we do here. If it worked for magnetos, what about transmissions, axles, engines? What about the entire car? October 7th, 1913. Ford was ready to test the full chassis. A 150-foot line, 140 assemblers stationed along parallel rails. The chassis moved past them on a rope and pulley system. Each worker performed one specific task: installing wheels, mounting the engine, connecting the drivetrain. Nothing else. In 9 hours, they produced 435 chassis. Assembly time had dropped to 2 hours and 57 minutes. By December, the line had doubled to 300 feet, with 177 assemblers producing 606 chassis daily. When endless chain drives replaced manual pushing in January 1914, and 3 parallel lines reached full operation by April, Highland Park was producing over 1,200 chassis per 8-hour shift. 93 minutes each. One Model T every 3 minutes. The number that took 14 hours in September 1913 now took 93 minutes. Ford had broken manufacturing. But breaking the process created a different problem. The workers couldn't handle it. 1913. Ford's annual worker turnover rate hit 370%. Think about that number. Really think about it. The company hired 50,448 workers to maintain a workforce of 13,623. For every 3 people Ford employed at the start of the year, 11 different people cycled through those jobs by year's end. The fastest production line in America was hemorrhaging workers faster than it could train them. The assembly line had made the work mind-numbing. Install the same bolt, turn the same screw. Repeat 8,000 times a shift, every single day. No variation, no skill development, no sense of completion. Workers quit after days. Some lasted hours. Absenteeism exceeded 10% daily. Ford calculated this churn cost $1,820,000 annually, equivalent to $46 million today. And that was just the direct cost. Training new workers disrupted production. Line stoppages from inexperienced hands cost thousands in lost output. The machine Ford built was eating its operators. He needed a way to make workers stay. January 5th, 1914. Ford announced something nobody in American industry had ever tried. The $5 day. Newspapers called it the most remarkable business announcement of recent years. Workers earning $2.34 per day would now make $5, more than double. Headlines everywhere. But the reality was more complicated. The $5 was not a flat wage. It was a profit-sharing plan with 2 components. Base wages remained at approximately $2.34 to $2.70 per day, unchanged from previous rates. The additional $2.66 came as a profit-sharing bonus, conditional on meeting strict requirements. Workers had to abstain from alcohol, not physically abuse their families, keep clean homes, contribute to savings accounts, not take in boarders. Initially, only male employees over 22 were eligible, approximately 90% of the 22,000-person workforce. Women were excluded until October 1916. Ford's sociological department, employing around 150 investigators, conducted home inspections to verify compliance. Investigators arrived unannounced. They checked cupboards for alcohol. They interviewed neighbors about family conduct. They verified bank deposits matched savings requirements. Workers failing to meet standards entered a probation period with supervision for up to 6 months. Those who continued to fail had their profit sharing suspended. The $5 day was not just compensation, it was surveillance. Ford had created a system where higher wages came with surveillance. But it worked. The numbers proved it. Within 2 years, annual turnover fell from 370% to 16%. Absenteeism dropped from over 10% to 2.5%. Productivity increased so dramatically that unit labor costs actually decreased despite the wage increase. Ford had bought loyalty, and he had created a workforce stable enough to run the fastest production line on Earth. Before Ford could scale production, he first had to win a legal war. November 5, 1895. Patent attorney George Selden received United States Patent Number 549160 for a road engine combining an internal combustion engine with a carriage body. Selden never built the car. The patent covered every gasoline automobile in America. In 1903, the Association of Licensed Automobile Manufacturers was organized to enforce the patent, and ALAM collected royalties from compliant manufacturers. Ford was not compliant. October 1903, ALAM filed suit against Ford Motor Company. Ford's response was characteristically defiant. He ran newspaper advertisements disputing the patent's validity, and he offered to indemnify any customer sued for buying a Ford. His stated position was simple. The car was the product of his own brain, and no man on earth was entitled to any rake-off from that car. The legal battle lasted 8 years. The initial September 15, 1909 ruling favored ALAM. Billy Durant and General Motors paid $1 million in back royalties. But Ford appealed, arguing the Selden patent covered only Brayton cycle engines, while all modern automobiles, including Ford's, used Otto cycle engines. January 9, 1911. The U.S. Court of Appeals ruled decisively for Ford. The victory freed all manufacturers from royalty payments totaling approximately $5 million collected under the patent. Ford became a national hero, the man who defeated the automobile cartel. And with that legal threat eliminated, he could finally scale production without limits. The numbers that followed tell a story of exponential growth almost difficult to comprehend. Fiscal year 1909, 10,660 Model Ts were produced. By 1913, when the assembly line began, 170,211 were produced. After full implementation in 1914, 202,667 were produced. By 1917, 735,020 were produced. The peak came in 1923, 2,011,125 Model Ts. That was the highest annual production figure ever achieved by a single automobile model, a record that stood for decades. At full capacity, Highland Park and later River Rouge produced 9,000 to 10,000 cars daily. One Model T every 10 seconds at peak. Price reductions paralleled production increases. The 1908 touring model cost $850 when average automobiles sold for $2,000 to $3,000. By 1914, assembly line efficiencies had dropped the price to $490. The lowest point came in 1924, $260 for a runabout. A car that cost $850 now cost $260. That was a 69% reduction. By 1921, Ford held roughly 56% market share versus General Motors' 12.5%. The Model T had become America's car. But here's the pattern that matters. Ford's greatest strength was about to become his fatal weakness. Alfred Sloan became General Motors president in 1923. He understood something Ford refused to see. Markets evolve. Customers change. Ford had built an empire on standardization. The Model T remained essentially unchanged from 1908 to 1927. Ford's famous line was painfully literal. Any customer can have a car painted any color that he wants, so long as it is black. Sloan's strategy was the opposite. A car for every purse and purpose. Chevrolet, Pontiac, Oldsmobile, Buick, Cadillac. A brand ladder with slightly overlapping price ranges, encouraging customers to trade up as income increased. Beginning around 1923, Sloan introduced annual model changes designed to make previous year's models appear dated, stimulating replacement demand even when existing cars still functioned perfectly. General Motors added what Ford dismissed as unnecessary: variety, color options, closed bodies for all-weather driving, consumer financing through GMAC, allowing buyers to pay over time rather than saving for the full purchase. Systematic used car trade-ins that created a secondary market. Aggressive styling that made last year's model look dated. By 1925, General Motors passed Ford as the largest manufacturer. The man who invented modern manufacturing was losing to a company that understood modern marketing. When Ford finally discontinued the Model T on May 26, 1927, closing factories for months to retool for the Model A, the shutdown was so significant it temporarily affected measures of American industrial productivity. By 1936, Ford had fallen to third place with just 22% market share, behind General Motors at 43% and even Chrysler at 25%. The assembly line that built Ford's empire had made him inflexible. He'd optimized for one product so completely that changing direction required shutting down everything. Was that single product focus strategic genius, or a trap he built for himself? I'm genuinely curious what you think. Drop it in the comments. But the principles he discovered didn't die with the Model T. They evolved. 1950. By then, Toyota Motor Corporation had produced only 2,685 automobiles in 13 years. Managing Director A.G. Toyoda spent 6 weeks at Ford's River Rouge complex, which at the time was producing 7,000 to 8,000 vehicles a day. Toyota's assessment was blunt. "I felt that I was being honest in saying Ford's not doing anything we don't already know, but their daily output was 8,000 units. Ours was a piddling 40. Yet, I didn't think there was such a large gap in technology. The difference lay mainly in the scale of production." Taiichi Ono, who became the father of the Toyota production system, took Ford's continuous flow principle and refined it beyond Ford's imagination. Where Ford pushed massive quantities through the system, building inventory at every stage, Toyota created just-in-time manufacturing. Producing only what was needed, when needed, in the amount needed. No warehouses full of parts waiting to be used. No finished cars sitting in lots waiting for buyers. Ono's crucial insight came not from Ford's factories, but from American supermarkets. Customers took what they needed at the moment they needed it. Shelves were restocked accordingly. This pull system, using Kanban cards, replaced Ford's push approach. The Toyota production system retained Ford's continuous flow and standardized work while adding Jidoka, built-in quality where any worker could stop the line for defects, and Kaizen, continuous improvement with workers as problem solvers rather than interchangeable parts. Ford treated workers as extensions of machines. Toyota treated them as the machine's supervisors. Ford moved the chassis past the worker. Amazon moves the shelf to the worker. In Amazon's fulfillment centers, robots bring entire pods of products to stationary pickers, eliminating miles of walking. The Proteus autonomous robots now move carts in areas shared with employees. Over 1 million robots have been deployed across the network. Same principle Ford discovered in 1913. Bring the work to the worker. Ford's line was repetition. China's electric vehicle lines are repetition plus model switching. Robots keep the rhythm while the product changes. One car every 60 seconds at peak efficiency. high-mix robotic cadence with artificial intelligence calibration that Ford could never have imagined. BYD's vertical integration, producing batteries, power electronics, and vehicles under one corporate structure, echoes Ford's River Rouge concept, where iron ore entered one end and finished cars emerged from the other. Control the supply chain, control the output. Highland Park optimized one car until it could run forever. SpaceX's Star Factory aims for the same cadence, but with a design that keeps changing. The long-term goal is one Starship per day. 700,000 square feet of production space are under construction, with completion targeted for December 2026. A dedicated facility tuned around one product family, redesigned around flow. Ford would recognize the principle immediately. The assembly line Henry Ford perfected between 1908 and 1913 represents one of the most consequential innovations in human history. Not merely a manufacturing technique, but a transformation in how societies organize production, value labor, and create wealth. Chassis assembly time dropped from 14 hours to 93 minutes. Annual turnover fell from 370% to 16%. Prices declined from $850 to $260. Production scaled from 10,660 to over 2 million annually. 93 minutes. Modern automation has largely solved the safety crisis Ford's workers endured, but the obsession with flow remains. Yet Ford's legacy is paradoxical. His methods created unprecedented productivity, but also dehumanizing work. In 1916 alone, Highland Park recorded almost 200 severe injuries involving amputation or loss of digits. Over 75,000 cuts, burns, and puncture wounds occurred that same year. The speed that made cars affordable came with a steep physical cost for the workforce. His $5 day raised living standards, but required surrendering privacy to company investigators who checked your cupboards and interviewed your neighbors. His standardization made cars affordable, but ultimately cost him market dominance when consumers demanded variety. What endures is the principle underlying every innovation: systematic analysis of work, elimination of waste, relentless focus on flow. Whether in Toyota's lean manufacturing, Tesla's unboxed assembly, or Amazon's fulfillment algorithms, the fingerprints of a mechanic who won a race in 1901 remain visible on the infrastructure of modern life. Ford was not just making cars, he was inventing the future of making things. And if you want to see how leverage works at the highest level of government, the next video shows how one banker dominated American economic policy for 11 years. Subscribe if you have not. That is the melon pattern.